Welcome back. In the last video of the topic, topic number 80, that's the logarithm and exponential equations. Right, so in the very last tip, here we are to discuss on how we can solve some problems that were here and there. They may need the application of the laws. Right, so which means like it was in the past, those problems were direct, but this time around, they are a little bit tricky and they need us a simple application. Sometimes without the laws, we may not work out on them, but they're not difficult, just simple. Right, so we will discuss this better in the form of the example. So allow me to write the examples. Right, they will ask you to solve the equations. L. The first equation is this one here. Say solve the equation. Logarithm of x plus 4 is equal to logarithm of 2x plus 3. B, we have logarithm of not just logarithm but 3, logarithm of x minus logarithm of 2 is equal to logarithm of 32. And the very last one here, we'll have that's a 2.237 to the power x is 5. Right. So here, every problem has got its own M. It means there's a knowledge that you need always to get. They look the same, but they're different problems which demands different approaches. So here we are, but what we discuss by one example, that will not be ruled out differently from the rest. Everything will be applied the same, but only that we may just admit in other situations that's like. But the approach is almost the same. So like for A, how do we find the value of x in that equation, right? So here I have to write a first of all solution, right? So we have A, logarithm of x plus 4 is equal to logarithm of 2x plus a 3, right? So somewhat, you always think about what we have been doing in the past in other areas of concern where you have been solving some equation. Like you compare by what you have here, you'd also be thinking of like terms together, but this time around you don't have that. And other measures like say quadratic equation, direct, they cannot work here. So now in the logarithmic equation of this kind, how do we do it? Right, so now how to handle this one out, that ways, how you can understand this one out, just now by the virtue of the presentation of the equation. You can be able to understand that the moment one says left hand side is equal to right hand side. That's what it means here. If I let this is equal to this, it's simply whatever I have here the same like that, no matter what. So like here now, if you look, say, if I'd like to take the logarithm of this, whatever logarithm I'll take for this one, because I don't know the meaning of the variable x, that should be exactly the same as logarithm of what? 2x plus 3. Otherwise, if the logarithm of this one is not the same as logarithm of this, then this is not true. Then here we have to write what? The equation here should be not equal to. That's one way how you can understand one. Meaning just to say what we have on the left hand side is exactly the same as the right hand side. So if you are taking the logarithm of a certain expression, this left hand side, that should be exactly the same as logarithm of what? The other expression down here. So what we should expect in this case, by the equation we have here, it means exactly that, say, if I talk of the logarithm of this is equal to this, then differently we should expect x plus 4 should be the same as what? 2x plus 3. There's no way that this expression can be different from this one. If we are saying log of this is equal to log of this is more like a experimental equation. Right, log of this is that one, it means then this should be equal to this one. Otherwise, then this is not true. Right, on one way allowed, in one way or another, we call out the antlog to say whatever I'll have for this one is the antilogarithm, and here again the antilogarithm for this one, or more you can just say the antlog. This is the logarithm of this one, the number of, you talk of the antlog of this one, just like the opposite of the logarithm should be the same as the antlog of this one here. If that one is not applicable to you, just take it as what I'm trying to explain it to you here. If you can't understand what it means by the antlog, just take that, say, when we're given the equation like this one, we have to pick that, say, the left-hand side should be the same as the right-hand side. So it's more like you have got the expression on the left-hand side, x plus 4, expression on the right-hand side as 2x plus 3. So if somebody picks up the logarithm here, that should be the same as logarithm of the other part. So what we expect here, should expect that this expression should be the same as that one. Or the antlog of this is the same as antlog of this logarithm. So the antlog of this one is x plus 4, antlog of that one is x plus 3. So here we have x plus 4 is equal to 2x plus 3. So which means we have got this one. It means you are already there of what we have been doing in the past. Just bring like terms together and find the value of x as large. But what is more important, just understand the logic that is from here up to here, then everything is just clean. We don't have to worry much. So here I've got x here, this comes here to be negative 2x. By like them together, we have the 3, and this comes here to be negative 4. Look at that. So I'll take x minus 2x, this is negative x, and here I'll get negative what? Negative 1. So which means I could divide both sides by negative in order to find the value of x. I'll have here negative into negative x is x, and negative into negative 1 is what? Is a 1. It's just simple as that. So it means here, it means wherever I vote x, there must be 1. And it's true. If I write 1 here, it will be log of 1 plus 4 is 5. And here I write 1 there, it will be log of 2 plus 3 is log of 5. So it's really true. Log of 5 is equal to log of 5. So it's true what we have done here. Fine, that one. So take that approach, but don't memorize, but just try to understand what we have done there. Now, what if now we have got more than one term on one of the sides? Like here, there's only one term in terms of expression in logarithmic and one term on the right-hand side. But if you can look at this one here, we have got two terms. This one is subtracting this, while here there's one term. Are we just going directly to do the same, to say that if this is equal to this, then again this is that? But here now, how is it going to work? Right. So to such kind, if you feel this cannot work directly as it is for the first one, it means you have to find some tactics on how you can handle that one. Right. So the only way how you can find the applicable approach for that mathematically, you have to understand what type of problem do you have. It's about logarithm. Then you have to revisit what we have just discussed earlier about the what? Laws of logarithms. Right, now let's see what we will have in this equation by following the laws of logarithms. Right, so let's see example B now. This is 3 logarithm of x minus logarithm of 2 is equal to log of 32. What do you mean by following the laws of logarithm here? You can just try first of all to see and consider which part is giving you a problem, or say is somehow a little bit different, and that maybe prohibits you from doing what you have been doing in the first example. So you're going now to have a closer look on the terms in terms of expression as such. You begin by looking at this one, and they look at the other one, and they look at the last expression in the logarithmic equation as such. You find that when you have got a situation like this one here, this tells us a story about what it is about the laws of logarithms. 3 log of x minus log of 2 on the left-hand side. This can be treated as 3 logarithm of x to base 10 minus the log of 2 to base 10. So you can bring in the law of the addition that's subtraction and division to handle this one out. What we need definitely here, we would need that the left hand side should be one expression. Like here, we all just have this one here and compared with one expression on the right hand side. So if we take the nth log on both sides, it should be what expression we have here should be equivalent to the other one here. But here we've got two terms on this, but here there's one term. So we're trying to make the left hand side to have one expression in logarithm as such. So that what we've done in example A should work similarly as in the situation we have here. So what do? You look at the terms first. If I can look at this one here, I found that this one is 3 log of x, then this one is subtracting log of 2. So to make this one a single logarithmic expression, what I need to do is, already I know that with the subtraction, it means that this logarithm of x here should be divided by what? Sorry, talk of x here, anything about x here should be divided by what? By the 2. If you can have a closer look about the closer look on the law number 2, where we are subtracting and dividing, that law is what is needed here. But you cannot just go it direct because of what we have here. So if you are going to think of dividing what is there about this, that's the x of this kind, by what you have here as a 2, you first have to handle a 3 as such. Otherwise, if you leave the 3 like that and you hand just x and a 2, that mathematics is not all that a correct one. So then we will need first of all to incorporate another law, which is law number 3, as per our discussion, in order to omit the 3 as the coefficient of log of x. So when you write 3 log of x, you bear with me that this is the same as the logarithm of x to the power 3. This one comes on top. You remember that law. Then minus logarithm of a 2 is equal to logarithm of 32. Then after, for you to make the left hand side having one expression, you now follow the laws of what? Logarithms themselves above the division versus the subtraction. So we have got log of x to the power 3 minus log of a 2. This is the same as logarithm of x to the power 3 over a 2 divided by 2, which is the same as logarithm of 32. Once we have done this, now we are happy. Here there's one termed expression, left hand side, and right hand side there's one lefty. We have also one talk of the logarithmic expression. As such, by the knowledge that I introduced earlier in the first example, you'll be able to take it that say if you talk of the log of x cubed over 2 is equal to log of 32, then definitely the nth log of this, which is x to the power 3 over 2, should be the same as nth log of this one, which is 32. So I take the nth log of this one, I get that's a 3, that's x cubed over 2 is equal to 32 as such. Right. So now if this is equal to this, then the rest of the story is applicable. Just clear this fraction and then you find the value of x. Because directly you cannot find the value of x as it is. You need at least first of all to deal with that fraction. So how to handle the fraction? Multiply both sides by the denominator, which is a 2. We have x to the power 3 over 2 times 2 is equal to 32 times 2. And here it goes as x to the power 3 is equal to 64. Right. Then from there, you can express those terms to the same basis or the same exponents. Because that what you have now is an exponential equation. So if I'm to express this to this term, I'm express the two terms, x to the power 3 and the 64 to the same basis, that won't work. But if I may think of expressing them to the same exponent, I'll have x to the power 3 is equal to 2 to the power, 4 to the power 3. 64 should be expressed to base 4. Right. So here we have x to the power 3 is equal to 4 to the power 3. So if exponents are the same, so why should we not have bases being the same? Otherwise, it means the equation is not correct. So if bases are this, exponents are the same, then definitely the basis must also be the same too. It means from there the value of x is 4. That's just like that. So please see the difference between example B and example A. How do they differ? More terms, try to fix them into a single termed expression on both sides. Then after, you need to work out for the variable which have been asked. Or what you do, please allow the laws of logarithms to take your guide. Right. Now, what about the last one? What knowledge should we have in relation to the last problem here? Is everything that we've discussed in A and B going to hold water here? Let's see. For C, we have got 2.237 to the power x is equal to 5. It's an exponential equation as such. So for x, a trouble will be there. As much as we know how to work out the exponential equation, we always consider expressing terms to the same basis or to the same exponent. So if you look at it here, the base is 2.237. Now if you like to make 5 to base 2.237, that can take you time. Right. So a situation like this, sometimes we at least handle it, we can handle it differently, of which I need you also to take it and master that knowledge of such kind. Suppose you are failing to pick up the basis to make the terms to the same basis as you have it here. One way how we can do it, since here we're given that this is equal to this, it means the left hand side is equal to the right hand side. So whatever measures will be applied, will be done on the left hand side, that should be the same to be done to the right hand side. If I add a 2, here I have to add the 2. That is now if I'm not to evaluate the laws of what? The equation. So what I'll do here, in order to bring this one down to find the value of x, what I can do here, I can think of getting the logarithms on both sides, right? So say for example, if I take the logarithm of 2.237 to the power x, then here you should also take the logarithm of what? Of a 5 in order to balance up. So if you take the logarithm on both sides, it means log of this one should be the same as log of a 5. So if this one is true, then now let us look at this one now separate. Log of 2.237 to the power x. Remember here the base is always a 10. So if you go by the rules of logarithms, you understand that this one now will come in as the coefficient of log of 2.237. So this will turn out to be x is equal to logarithm of 2.237, and the right hand side is logarithm of a 5. Here we have not equal to, but x just comes here. X log of 2.237. Right. So this how come about? It's because of the laws of logarithms. You can see which law is demanding us to do this. So once that is true, you always bear with me that logarithm of 2.237 is just like a single number, which of course is a decimal number. And again here, logarithm of 5, you can find it. So it's more like now, logarithm of this one will turn out to be the coefficient of x. So if I would like to find the value of x, here I need just to divide by logarithm of 2.237. Here again, I also divide it by the same measure. Remember, we do the same on both sides of the equation without changing. So you also divide by 2.237. Right. So this and this will cancel, and you have got x. So if you look at this one, what you do, you just have now, here you have got no choice, but rather to go straight and use the calculator. So you have to get the logarithm of a 5 and write on top that should be divided by logarithm of 2.237. So if what I have in the book as such, I know you can use the calculator. It's not all that difficult. You find that the logarithm of 5, this one is 0.6990. While logarithm of 2.237, that one is 0.3500. So it means that the value of x will come out of this, the quotient of this and this. So what you have there is just like when you divide this into that, you find that the value of x comes in as 1.999 something here, like a 7. So if you correct that one to at least maybe 2 or 3 decimal places on this whole number, you find the value as a 2. That's all. Right, so that's it. And you'll be meeting different types of equations in logarithm. Please think about it just in detail based on what we have just learned in the topic. So this, my dear students, this marks the discussion of the entire topic about the exponential and logarithms. And I hope that whatever I've discussed here will be able to help you to handle different types of problems that comes in terms of exponential and logarithms. So to go out, you have some past papers and check what is there in the book, in the past papers, also in the books, what is there. You have got mocks from different schools. Try just to sit down with your friends while you study this, you watch the videos, try to sit down and again solve some problems so that the knowledge should be advanced. Thank you very much. But maybe just one problem that you can maybe use it to wrap up the entire topic, because you cannot just close the topic yourself like that. Have this one. Right, solve the following equations. One, you talk of 7 to the power x plus 1 is 50. And number B, I'll give you this one out. 1/3 logarithm of 125 minus log of y squared is equal to log of 125. Right. So just work out on the A and B such. But otherwise, thank you very much for interacting together until at the very end. Thank you.